Hello, my name is Francisco, and this is a re-recording of my presentation from the Airborne Wind Energy Conference 2024 that took place in Madrid. And the topic of my presentation was a small-scale ground station for airborne wind energy that has been developed by la Universidad Carlos III de Madrid and Z Ingenieros. And let's first introduce the team that has made it possible. So, on the one hand, we have the University Carlos III. Research on airborne wind energy started in 2015 by Professor Gonzalo Sánchez Arriaga from the Aerospace Engineering Department. And recently, in 2023, Professor David Santos Martin joined the team from the Electrical Engineering Department. On the other hand, we have Z Ingenieros that joined in 2021 and is specializing regarding airborne wind energy on simulation, control, modeling, site identification, regulation, and other engineering services. The experimental capabilities of UC3M have evolved during the years. It all started in 2016 with the PhD thesis of Ricardo Borovia and his sensorized control bar for the aerodynamic characterization of kites. Later on, during the PhD thesis of Ivan Castro Fernandez, an autonomous testbed was developed for the same purpose and also for visual motion tracking research. And then in 2022, we developed an evolution of that testbed with increased capabilities, pitching control, and better sensorized for autonomous control. And this is the architecture that we have used as a base for our airborne wind energy system demonstrator. So in February of this year, this is a video from Santa Maria de Alameda, our test site in Madrid. We demonstrated autonomous flight with the current testbed. So this was a good validation that the architecture makes sense and is a good base for the new system. And we had three main goals for the design of this prototype. First, we wanted to build a proper technology demonstrator, although small scale, 15 kilowatts of rated power. Then we wanted it to be universal, as flexible as possible, so we could test with fly-actuated kites, ground-actuated kites, one line, three line, anything that we wanted, we should be able to test with this machine. And finally, we wanted it to be a proper scientific tool, so we incorporated as many sensors as needed to gather scientific data for research. So this is the design that we achieved. Mechanically speaking, it is designed to fit on a flatbed, on a commercial vehicle, and it can operate 1 to 3 line aircrafts and up to 4,000 newtons of combined tether force. Regarding the electrical system, it can operate both connected to the electrical grid and also isolated. And it has a battery system to smooth the output of the power generation. And it's a microgrid, so it can combine both airborne wind energy and other sources of power, such as photovoltaic panels. This is a picture of the prototype mounted on our track that was showcased during the conference. And now let's walk through each subsystem, and let's start with the architecture of the prototype. Of course, we have the kite with an autopilot and its GPS system, a set of load cells mounted directly on the kite, and a multi-hole pitot tube system. Then we have on the ground a visual motion tracking system and an angle sensor. With the anemometer, the flight controller steers the kite to perform the figures of 8, and is coordinated with the electrical and energy storage subsystem through a main control unit, which is a PLC and a central SCADA. For the outer part of the machine, we decided to build a line orientation system it was not feasible to move the whole machine to orient it to the wind, but we still wanted to be able to orient the output to the kite and towards the wind. So we came up with this semicircular design. It features a carriage that incorporates the tensiometers and line angle sensor, and it allows for around 100 degrees of movement. Then for the actuation of the kite, when it's ground actuated, we have two sets of linear actuators. When we want to steer the kite, we just move the actuators on the same to the same direction. So one control line is shortened and one control line is made longer, and in that way we achieve steering. Then if we want to control the pitch, we just move both in different directions, so both control lines move compared to the central line, and that creates pitching. And in general, we have incorporated more capable servo motors, and now we will be able to test with a much wider range of kites than before. Regarding the powertrain, in order to achieve proper winding of the tethers onto the drum, we designed a moving platform mechanism. Both shafts are sensorized in position, velocity and torque to identify possible mechanical losses, and it has been designed with safety in mind, so the torque is limited to never exceed the maximum permissible values. In conclusion, ZT Ingenieros and UC3M have developed the first yo-yo type airborne wind energy ground station from Spain. It has been based on an architecture that has been proved to be valid for autonomous control, and it has a flexible design which will allow for rapid development and valuable scientific data for research. And regarding the future, the system has started a commissioning phase, so each subsystem will be tested and integrated properly. The generation and energy storage subsystem will go an in-lab testing phase to further develop the control algorithms. And finally, by the end of 2024, we expect the prototype to be ready for its first flight campaign to validate all systems on flight. And thank you for your attention. This work has been made possible by Industrial PhD grant from Comunidad de Madrid. And if you have any doubts or comments, I will be happy to reply in these contact emails. Thank you.